Welcome to ACI, the Network Made Simple learning series. In this video, we will cover Module 3, Configuring Logical Connectivity, Chapter 6, Fiber Channel and Fiber Channel over Ethernet. In Module 2, Chapter 7, we covered an overview of storage protocols and unified fabric on ACI, as well as the physical network configuration to connect FCoE and FC based on the display topology. If you remember, once we had finished performing the physical network configuration, our fiber channel interfaces were still down, and there were no virtual fiber channel interfaces available. The reason for this back then was that, just like with LAN networking in ACI, SAN networking needs the logical network configuration as well, and this is exactly what we will do in this chapter. By the end of this video, and based on our topology, my ESX VMware server, which currently has a Converged Network Adapter or CNA, should see its fiber channel storage array, which currently shows disconnected, and all its virtual machines automatically available. In order to achieve this, we will follow our well-known steps to configure the logical network for our SAN this time. The main difference is that we will not be using contracts nor L3 outs. We will start with the fiber channel configuration, which connects our ACI leaf nodes to the MDS switches. And then we will continue with the FCoE configuration for the server side. Let's get started then. The first step, as you know it, is to create a tenant and a VRF. We will go to our APIC, and in the tenant section, we will click on Create Tenant, and we will call this one Unified Fabric, along with its VRF called Unified Fabric VRF. Step 1 is now done. Moving on, and as part of Step 2, we need to create an application profile. We will simply call it SAN Access. If we now click on its topology view, you can see that it is currently empty as expected. So let's fix that by moving on to Step 3. We will create a couple of EPGs, one for each vSAN, and we will also create and map a bridge domain for each of them. There are two main differences I would like you to consider in this case versus what we have been regularly configuring. The first one is that the bridge domains will be type fiber channel instead of regular. And the second one is that once I create the EPGs, I will have to assign a QoS class that supports lossless Ethernet, since the fiber channel over Ethernet ESX servers will use these vSANs as well. In our case, we will simply leverage our configuration for Module 2, Chapter 7, where we enable priority flow control in QoS Class 1 as part of our access policies. Keep in mind that this configuration is only needed for FCoE scenarios, so if you have fiber channel on both initiators and targets, you will not need to do this. Let's now go back to APIC and configure this. I will start with the bridge domains. In the networking section, I will right-click on bridge domains and I will create the first one for vSAN 101. I will set its type as fiber channel, and then I will assign it to my VRF. I will now do the same for vSAN 201. And just like that, we have finished creating our bridge domains. Now, let's go back to our SAN Access application profile and create our vSAN 101 EPG. Since we will have FCoE servers using these vSANs, we will select the QoS class that has priority flow control enabled. In our case, that is level 1. Remember that this is only needed if you have FCoE initiators or targets like I do. Last, I will map its corresponding fiber channel bridge domain, and we will be done. I will repeat the same process for vSAN 201 EPG now, assigning the right QoS class and fiber channel bridge domain as well. Done. The last thing we need to do now is associate our fiber channel domain to each EPG. So let's go to the menu on the left, maximize our vSAN 101 EPG first, and then in the domain section, I will associate my fiber channel domain, which in our case is named SAN. Then I will specify on which ports I want to enable my fiber channel connection. In our case, we have MDS-A connected to leaf 201 on port fiber channel 117. Therefore, I will click on Fibre Channel Paths, I will select Leaf 201, port Fibre Channel 117, and I will specify that I want vSAN 101 flowing through it. I will set this vSAN mode to native, since there must be at least one native vSAN on every link you provision. I will now do the same for vSAN 201, associating my SAN Fibre Channel domain as well, and selecting Leaf 202 this time on port Fibre Channel 117. Since I have no existing vSANs traversing through this interface so far, I will also assign vSAN 201 as native. Good. Now, if we go back to the topology section, we can see both EPGs for vSAN 101 and 201 mapped to a Fibre Channel SAN domain, which is represented by the bare metal icon. It seems we're done with our Fibre Channel uplinks configuration. Let's verify this by going back to the Fabric section, and if we go to the Leaf nodes and click on Interfaces and then Fibre Channel Interfaces, you should see that Fibre Channel 117 is now showing up as expected. Don't worry if you initially see a fault there, like in this case. Just make sure you verify it and that its status is showing as clearing, and it should be automatically removed a few seconds after. Just for the sake of it, let's do the same now for Leaf 202, where we can now see that our Fibre Channel uplink is up as well. And then, if we now switch to one of our MDS switches console, we can also see that port Fibre Channel 135 on this side is also showing up, which in this case verifies that both the ACI and MDS layers are successfully connected. Now that we have finished our Fibre Channel uplinks configuration, let's now proceed to do the same with the Fibre Channel over Ethernet side of it to have our ESX servers connected to the storage array. We will use the same tenant, application profiles, and vSAN EPGs we already created. However, there is one more thing we need to do. As you may remember, and based on what we covered in Module 2, Fibre Channel over Ethernet relies on the FCoE initialization protocol, or FIP, and it will need its own EPG and Ethernet bridge domain to succeed. Therefore, I will go back to APIC and I will start by creating my FIP bridge domain. I will call it FIP-BD and assign it to my VRF. Then, I will go to the EPG section and I will create its EPG. I will also set its QoS class to 1, and I will assign the bridge domain I just created to it. Good. Now, to finalize our configuration, I will need to statically map my ESX server's physical domain to each EPG so that we can extend each vSAN as well as our FIP VLAN to it. Let's start then with our FIP EPG. I will maximize it, I will click on domains, and I will add a physical domain association where I will select my physical domain from Module 2, which I called FCoE_FIP, and then I will map the port where my ESX server is connected. In this case, this is a virtual port channel connection between Leaf 201 and Leaf 202, which is called VPC_ESX1. Since we had defined VLAN 1 for FIP as part of our VLAN pool, and the server will not be tagging FIP traffic according to our CNA settings, we will select the access port 8.2.1p option and assign VLAN 1 to it. I will also choose the deployment immediacy to be immediate so that this is programmed on the switch right away. Great, it seems our FIP EPG is now fully configured. What is missing? Well, we also need to get vSAN 101 and vSAN 201 extended to the host through the virtual port channel, right? So, let's simply maximize our vSAN 101 EPG and assign our physical domain there as well to allow FCoE VLANs to flow through it. We will then deploy Fibre Channel statically, indicating that we will want vSAN 101 to flow on our VPC. We will then set such vSAN to native, since this is the first vSAN we are enabling on this link, and we will be done with it. Now, we will do the same for vSAN 201 to provide redundancy on our VPC. Let's do this by maximizing vSAN 201 EPG, assigning our physical domain there first, and then we will deploy Fibre Channel statically to the same virtual port channel, this time adding vSAN 201 to it as a regular vSAN, since this is the second vSAN flowing through our VPC link. That's it. Now, if we go back to Fabric, Inventory, and then click on Interfaces in one of the leaf nodes, we should see that virtual fiber channel interfaces are now showing, which are bound to the virtual port channel. And not only that, but we can also see that floggies from our server are now showing. If we now take a look on the MDS side, our active zone set shows that both the initiator and target have established communication by displaying a star next to each worldwide name. And now, if we go to the vCenter, we can see that communication to our pure storage fiber channel array has been successfully reestablished, and that VMs are available again using a mixture of fiber channel over Ethernet and fiber channel over our ACI fabric. As a summary, you can integrate fiber channel, FCoE, iSCSI, and many other types of storage networks directly on ACI, consolidating visibility and reducing the number of ports and devices you would otherwise need. Keep in mind you will always need the physical and logical network configurations to achieve this. If you will be using FCoE, just remember to use the right class of service where PFC is enabled so that lossless Ethernet can flow through your link.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.